In this lesson, we're looking at perimeter and area of composite figures. I assume that you already know that perimeter is the area, the distance around the outside of an object, and area is the amount of space, two-dimensional space that it takes up. So what might be new to you is this idea of a composite figure. Composite figure is one that's made up of two or more other figures. So let's just fill that in. Composite figure is, let's make this bigger so I can write a little bit neater. I guess that's as big as it goes. Made up, as in composed of, that's where the idea of composite comes from, composed. I'm going to call them regular shapes. So what do I mean by regular shapes or common shapes? Well, squares, triangles, circles. What else do we have? Trapezoids, rectangles, etc. All right, there's more. There's pentagons and octagons and parallelograms and so on and so forth, kites. But you get the idea. How do we calculate the perimeter of a composite figure? The same way that we calculate the perimeter of a common shape. We just find the total perimeter. So we just find the total distance around the outside. So if it's an irregular shape, then we just go along, we pick a spot to start, and then we just go along the outside and add up all the different lengths. Pretty straightforward. The area of a composite figure is straightforward too, as long as you get the idea of what we do. We mentally break it down and get the area of each of the parts that we're familiar with. So maybe it's made up of a square and a circle and a triangle. We'd get the area of the square, we'd get the area of the circle, we'd get the area of the triangle, and then we'd add them all up. By common, again, I mean regular. That's one way of doing it. There's actually a second way, so maybe I should mention it. Depends on the situation, but sometimes we need to subtract. So it depends. When you look at a picture, it should be hopefully obvious which one we're going to use. If something's just made up of a bunch of parts you can add together, we add them up. If something looks more like a big part, a big shape where something's been taken out of it, and we know we can find the area that has been taken out, then we should subtract. So let's take a look at some examples. First one, a garden is in the shape of a rectangle and a semicircle as shown below. What amount of fencing is required for this garden? Well, in this case, first of all, what do we use fencing for? Well, we use fencing to go around the outside of the garden. So would that be perimeter or area? I assume that you recognize that's perimeter. So if you take a look, there's a couple parts. There's the semicircle. Let's make this bigger. Here's the semicircle. And there is the part of the rectangle anyway. So we have this. What we don't want is this dotted line, unless there's some reason that you want to have a fence go down the middle of your garden, which I guess is possible, but there's nothing in the question suggesting that. There's nothing suggesting that we should have a fence going down the middle of the garden. So we don't want that perimeter there. So the first thing we could do is we could find the perimeter of the semicircle. In other words, remember, perimeter for a circle is called the circumference. Let's go back to smaller. So circumference is the area, or the distance around the entire circle. We want half of that because it's a semicircle. It's half of a circle. So circumference equals, remember, pi times diameter, or 2 pi r, 2 times pi times the radius, and that's only because the radius is half of the diameter. So the reason why these two formulas are the same is because d equals 2r, and then the pi is there for both of them. We want half of that, so the perimeter for this part, I'm going to label this, call this 1. So perimeter 1 is going to equal pi times what? What's the diameter? Well, remember, diameter is the length across the circle. So that's why, one of the reasons anyway, why we have this 10 meters here. We know that the diameter of the circle is 10 meters. But we want half of that, right? So the reason I'm dividing by 2 is because we only want half of the circumference. And so that would be, where's my calculator? Pi times 10 divided by 2 is 15.7. And the units will be meters, because that's what the other units are. The perimeter for the rest of this is going to be just, we don't need to do any calculations here. I'll call this part 2. Is going to be, if I start in the top left corner of the red, then I can go down, and I've got 7. So in other words, I'm going to go this way, and then I'm going to go across. So I'm going to add 20 to that, and then I'm going to go up, and then I'm going to go back over to here, and that's where I run out of red. And so that adds up to 44. So the total perimeter is going to be 15.7 from the semicircle plus 44 for a grand total of 59.7 meters. The Cutie Cupcake Company is having a sign made. The sign will be a semicircle on top of a trapezoid. How much steel is required to make the sign? Well, again, what are we talking about? In this case, we're not just talking about outlining it. We're not talking about a fence or going around the outside. We want to know the total area of what this sign's going to be made. Apparently it's going to be made of a couple pieces of steel, or maybe one piece of steel cut into this shape. But it's definitely two distinct areas, right? Let's stick with the different numbering again. So again, we got a semicircle here. And the semicircle is this. Now this time I am drawing a line down in the middle there because it's not perimeter. I'm just showing where the semicircle is outlined by. As for the other shape, do you recognize what that's called? Do you remember what that's called? It's got two parallel sides, and then these non-parallel sides. This is a trapezoid. So that's our other shape. I'll keep my coloring going, color coding going. So again, since it's made of two shapes, they're clearly just stuck together, it would make sense to use the first method here, the area where I find the area, or the method where I find the area of the common parts, and then once I've got them both, I'll add them together. So the area of a semicircle is, well, the area of a circle equals pi times r squared. That's a circle, not for a semicircle, but semicircle just means we take half of that again, right? So area 1 is going to be pi times, what's the radius? The radius is half the diameter, and the diameter is clearly 2. So half of 2 is 1, so pi times 1 squared, and I'm going to divide by 2 again. The reason why I'm dividing by 2 is because it's a semicircle. So 1 squared is 1, times pi is 3.14. Take half of that. I've got an area of 1.57, and the units will be meters squared because it's area. Now area 2 is a trapezoid. So the area for a trapezoid is equal, uses the formula A plus B times H divided by 2. And A, B, and H are these things here. So A and B are just the two parallel sides. So we could call this side A and this side B. It doesn't really matter. I could switch that around. H is the distance, the perpendicular distance between the two. So that's H there. And it doesn't matter which way you turn things. That's how it goes. So to fill in these values, it's going to be the A was 2 meters plus 1 meter for B times the height, which was 0.75, divided by 2. And when we put that all in our calculator, we get 1.13. And again, it's meters squared. And again, the total area is just going to be area 1 plus area 2. Don't forget, you should always put units down for area. The last example is the soccer goalie standing in an opening. From this position, she can guard the area represented by the semicircle below. How much of the goal is she not guarding? All right, so she's not guarding this area here. If someone shoots here, she won't be able to protect the net, and it'll be a goal, right? That's what the question's asking us. Hopefully, when you look at this question, you can see the clear difference between this one and the first two. This is one where we've got a shape, a rectangle, and instead of adding another shape to it, they've removed a shape. We're going to take away this area from the rectangle. Stick with green. And so we're going to have this shape here in green. That's just a rectangle. And from that, we are going to remove a semicircle of area. So let's call this area 1, the whole thing, not just that one little section of it, but everything that's in that green rectangle. I'll call area 1. We'll call this area 2. And area 1 is just a rectangle, so again, that would be length times width, which is 7.3 times 2.4, which is 17.52 meters squared. Area 2, as we already saw, is half of a circle, so it's going to be pi r squared, sorry, not pi r squared, sorry, it is pi r squared. Got confused for a second. But again, because it's a semicircle, I'm going to divide it by 2. Pi r squared is the area of a circle, but we divide it by 2 because it's a semicircle. And so that would be pi. You can either use the pi button on your calculator or 3.14. You'll get slightly different answers, but not enough to be concerned about for us anyway. And so 2.4, you can see is the radius, right? We can see the radius right there. So make sure that you understand that's the radius. Be clear on whether they're giving you radius or diameter. You can always switch easily between one or the other one. And that works out to be 9.05 meters squared. Then what we can do is add them together. Sorry, not add them together in this case. We're going to subtract. So we're going to take the whole rectangle and we're going to subtract, take away, that's a minus sign there, the area that is guarded. And we're left with 8.47. About half the net is unguarded, is what it turns out to be. So how much of the goal is she not guarding? 8.47 meters. So main takeaway here is you have to know your different formulas. Actually, what I will do, where is it? I have somewhere a formula sheet. Okay, I will post along with the notes, like beside the notes, something that says EQAO formula sheet, because it's got all the formulas you want on it. So it won't be included in this note, but right below this note I will post EQAO formula sheet, and it'll have all our formulas.